and see if it's working. So that but during the 30 minutes. Yes. Okay, so just a quick one. So we're looking for a cofactor of one saying cofactor, a minor of -3. So I hope you recall that we say we do a Candy Crush method. In so doing, we must look into -3. So we eliminate vertically and horizontally from -3, isn't it? From -3. Okay, from -3. From there, the remainder, we have our, I hope you remember. So we must say M, the subscript here, it must be M, M2, 2, right? Because element -3, it is in row 2, column number 2. So when they say do calculation or something, maybe for an example, they'll say determine M22. Then you'll know that, oh, I'm going to go second row, second column. And then you eliminate vertically where you have a bisection, there -3. That's the minor of you're looking for. So it will be equals to today, Babalas, well, I don't drink. So equal M22 is equals to the minor, it is 2, -6, and 6, and 0. So I hope you see that now the minor of the element -3, it is equals to, we'll have 2 times 0. So it is 0. Then we have minus -6 times 6. -6 times 6. So we have -36. That is a very important part. The formula is always minus. When we multiply, we had an output of a -36. So we can solve the problem, say it is equals to, we have a positive 36. That is the minor of element -3. But if let's say you're looking for its cofactor of -3. So I hope you remember the formula for a cofactor. So it's going to be A. We do the same thing. It's A2. It's A. It's in row 2, column 2. It is going to be equals to. Now I need to determine the output of that position. So n -3. We still do the same thing. Eliminate vertical, horizontal. But we need cofactor formula. It must be -1 to the power of I plus j. So we know it's in column row 2 plus column 2. Therefore, the minor multiplied by the minor of the element. So minor of the element, we just calculated up there, but just write it in the way. So 6 and 0. That is the minor of element -3. So in that case, we do the finalization. We know that a -1 to the power of an even number, because 2 plus 2 is 4. So we get -1 to the power of 4, which is +1 inside the bracket. So the output is a +1. And the rest is the multiplication then. We know, in fact, still the similar with the top solution here. So it's just 2 times 0, which is 0. Therefore, minus -6 times 6, which is -36. Okay, let me just drag it here. So which is going to be equals to 36, isn't it? So not to waste time. So 0 minus -36. So we have +36. That is the solution. Easy as it is. 3 marks. So we were just doing a recap and determinants. So a recap again, even in Cramer's rule. Cramer's rule. Maybe some still copy. So Cramer's rule, we apply it into 3 systems of equations normally. Even if there was 4, we could try and derive the equations, the elements, to say the determinants from that equation. I think it's in another book here. I'll say it's number 4. So we have equation 1, which is 3x. Okay, this is straightforward. I want 3 systems of equation. Okay, let me just take this one. This is number 5. So I want 3 systems of equations. So we have negative 2z to say plus 2y. It is equals to negative 3x. We have positive 3y minus 2 plus 3z. It is equals to negative 4x. So it's negative 4x. The other one, we have 2x equals to y minus z minus 1. Okay, that negative is not that clear. So let's have negative 16 minus 2z plus 2y equals to negative 2x. We need to solve for x and y. We need to solve for x and y. So solving for x and y, we need to deduce the determinants. But you cannot deduce the determinants before you simplify the equations to be in a form where we have x, y, z. So we must make sure we have x, y, z equals to the constant. X, y, z equals to the constant. If we are using other, let's say, variables, it must be in that order. Maybe something I1, I2, I3 equals to a constant. We have to do the same thing. So in the meantime, I say in the first equation, in the right-hand side, we have a constant mixture with z and y. So I just want to take x to the other side and take the constant to the right-hand side. So I'm going to rewrite the equation. Let me rewrite it in that case. So we rewrite the equation where we are going to have minus, now it's going to be 3x. Let me use the blue one, it's more faint. So I have 3x. We take 3x to the other side. So it must be followed by y. I hope you see y. It is positive, remain as positive. So we have 2y. Looking into z, z is still negative. So negative 2z equals to take 16 to the other side. The sign changes and become positive 16. And then the second part, the second equation, same thing, x is on the right hand side. We take 4x. It's going to be positive 4x. Followed by y, we have positive 3y. Then z is still positive, we have positive 3z. We have 2 there, which is negative. Take it to the other side. Change the sign and becomes positive 2. And the last part, x is positive. The last step to the equation to say. Then take y to the other side. Change the sign minus y. Z is going to be positive z. Equals to, the constant remains on the right hand side is still negative. The constant remains on the right hand side, it is still a negative value. So we need to solve for x and y. We need to deduce what we call our determinant. Deducing our determinant, it will be equals to the column. The first column will consist of the coefficients of x. The first column, what we're going to do, we're going to take this, we erase this, so we're going to take this values here of x, this was. Going to take that volume, values there. This is too faint. But I want to cycle the coefficients of x. So we're going to take the coefficients of x, they will be in the first column. So which means we're having 3, 4, and 2. So we take the coefficients of x. So we'll do the same thing when we have to deal with y. We're going to take the coefficients of y. Take the coefficients of y. So the coefficients there where we have it's 2, This is 2, 3, and minus 1. Take the coefficients there. So we're going to take 2, positive 3, and minus 1. Now, those are the coefficients of x, of y to say. Coefficients of y. And we move on. We take the coefficients of z. Coefficients of z in that order. So let me see there. We have negative 2, isn't it? And positive 3. Just, I'm saying something and I want to write it. And 1. So, but excuse my column there, which is jumping. I hope this is clear. That is a negative 2. Yeah. So we move on now. We need to solve our determinant. So to those who were here, remember I said that this one I put the note here. So we have to solve. First of all, we're looking into element 3. So we're looking into element 3. I think this will help me out here. I'm writing in the paper. So we're looking into element 3. So what we're going to do in element 3, we eliminate horizontally and we eliminate vertically. So what is remaining, that is our minor of the element. So we're evaluating using a cofactor method, cofactor expansion. So we know using cofactor expansion, the output is going to be positive. It's going to be positive. How we know that using cofactor? It's in row 1, column 1. So it's in row 1, column 1, element 3. So we know that, the output is going to be positive because negative 1 to the power of 1 plus 1 is positive 1. And we must multiply by element 3 and its minor. So I hope you see the elements which are left out there. It is 3 minus 1 and 3 and 1. We move on to the second evaluation. We move on to the second evaluation. So now we're going to look into element 2. So if you look into element 2, we're in element 2. So we're going to eliminate horizontally and vertically. Horizontally and vertically. So eliminating those elements. But first of all, we look into element 2. It is in row 1, column 2. So it's in row 1, but in column number 2. So that's why it comes out as a negative output, is negative 1. So that's why we'll say minus 1, therefore multiply by the element 2. I'll try to fit it in here. So the elements, the minor of that element, it is 4, 2, 3, and 1. And 1. So evaluating using a row, let's say a row evaluation. Now we need to move on and check the what is it? Evaluate using the last element and the last first row. First row. My 3 there is jumpy. But eliminate horizontally and vertically. Eliminate horizontally and vertically. So in that case, we eliminated horizontally, and we do that vertically. Do the handwriting there. So, but we know that it is in row 1 in column 3. So 1 plus 3 is 4. Then negative 1 all in all to the power of 4 comes out as a positive 1. Comes out as a positive 1. So hence in that case we know it's positive. Therefore multiply by the element negative 2 and its minor. So the minor of that element we know is going to be 4, 3, 2, negative 1. We can evaluate now. we can evaluate. So if an evaluation, not to waste time, we'll have 3. Therefore, multiply 3 times 1. So we have 3 minus. Always the formula, it's minus. Do not forget that. So negative 1 times 3. Negative 3. Move on to the second term. We're going to have negative 2 in bracket 4 times 1, which is 4. Therefore, minus 2 times 3. So we'll have 6. Close short. Then the last term, we're going to have plus. No, it's going to be minus. Minus 2 because plus that says minus. Therefore, we're going to say 4 times negative 1, negative 4, then minus 2 times 3. So we have 6, close short. Therefore, it is equals to. Now, in that case, if you want, you can calculate everything at once, or you can still do portion by portion to trace back if you've made a mistake. Most especially when it comes to the signs. I know signs, they're the killer. So it mess up everything. If here we have left one negative, most especially, it affects everything. So, but if you want, you can do this and say that you have 3 minus minus there, which is positive, which you're going to have 6. 4 minus 2 in 2. So 4 minus 6 is negative 2. Therefore, you'll have minus 2. So minus 4 minus 6. So minus 10. So I think here you can write the final answer because everything is clear. Having 12, 18 minus 4, which is 14, but minus 20. Positive 4, 22. So you are getting what? You're getting 42. Okay. So 42. Is it not? This is 4, this is 18, 22, this is 20, which is 42. Yeah. The signs they become positive, positive. So that is the solution. That is our determinant. We're not done solving for x. So we have deduced our determinant. We need to now determine our, where can I put this one? Okay. Okay. So it doesn't fit. So we need to solve for x and y. But with you, I'll do the solving of x. We'll solve for y. So some of you will remember that if we said we want to solve for x, we have to deduce the determinant of x or delta x. To deduce the determinant of x or delta x. Now, in doing so, how are we going to do it? Now, that's where we come in into looking into which. Okay, done copying. Just want to draw this part. So we have to look into the column that consisted of coefficients of x. I hope you'll agree with me that the column that had the coefficients of x is this one, isn't it? So start off. So if we want to solve for x, we have to replace the column of x by the constants. The column of x by the constants. The column that consisted of determinants of the elements from the coefficient of x by the constants. So we replace that column. We're going to take what? We're going to take the coefficients. We must take the coefficients. So we're going to take this constant to say, we take this constant, we replace the column of x by those constants. I hope it's still clear, we still remember. If you want to solve for y, you replace the column of y by the constants, and then solve the determinants of x. So we have to solve for x. We are replacing the column of x elements by the constants, which were 16, 2, and minus 1. Then the rest of the elements remains the same, which came from y and z. We just replace the ones from x. So we replace, and we'll have 3. Negative 1 is still the same. Negative 2 and 3 and 1. It remains the same. We just replace the column of x because we want to solve for x. And then from there now we solve our delta x. Solve our delta x. So solving for delta x, we do the same thing. We know using the first row to evaluate, it will always come out as a positive solution. Output is positive. Therefore, multiply by element 16. So therefore, we need to determine the minor of element 16 in that case. Erase this. So we do the same thing. So we're using element 16, we eliminate horizontally and vertically. So the remaining elements are the minor of that element. So it's 3, negative 1, 3, and 1. The second, from first row, second column, the output is negative. We're using my element 2 now. It's going to be negative. Multiply by element 2, and it's minor. And it's minor. So we are going to do the elimination. We're in element 2 now. You eliminate vertically and horizontally from element 2. The remaining of the elements are the minor, so it's negative 2, negative 1, 3, and 1. So that is the minor of element 2. Always close. Now we move on to the last part. It's going to be plus. If we evaluate from the first row. Now multiply by negative 2. Therefore, multiply by its minor. Multiply by its minor. So multiplying by its minor. So from element negative 2, we eliminate vertical and horizontal. The element that are remaining is 2, negative 1, and 3, negative 1, isn't it? So therefore, we can evaluate delta x. So quick, it's going to be 16. Open bracket. So 3 times 1. 3 times 1. 3 times 1. Yeah. I don't expect 2 people to respond. The whole class. So minus 1 times 3. So I have minus 3. I hope you see what happens. Always the formula is minus. I'll always repeat this. Always the formula is a minus. But make sure the output that you get of a negative, please make sure you input it there. That's where most get it wrong. So please, I'm repeating so that don't forget. Then you'll have minus 2. Then 2 times 1. So I have 2 minus negative 1 times 3. So negative 3, close shop, close shop. Therefore, minus 2 in the last term here. So 2 times negative 1. So it's negative 2 minus negative 1 times 3. So I have negative 3. Close shop. Therefore, the answer is going to be equals to. As I said, if you are good in punching your calculator and you have traced everything correctly, in this step, please calculate everything at once. But if you want to do step by step, do so. And have that's 6, right? So 3 minus 3. And therefore, this is minus 2 into. This is going to be 5. And the last term, minus 2 into bracket, minus, minus, minus. Now this becomes 1, isn't it? So negative 2 plus 3 is negative. Did I say negative 1? It's positive 1. Then you can calculate everything at once. Calculate everything at once. Okay, so the solution is going to be equals to, yeah, that's negative 10 and negative 12, then 6. So you say 80, 84. I hope everyone is getting the same answer. We have 84. And therefore, from there, you're going to say x is equals to. When you solve for x, we know that x it is equals to delta x over delta. So x is equal to, so delta x we just calculated, which is 84. Then all divided by delta. Delta we calculated here, it's 42. So it is 42. Then we'll have the value of x. So the value of x is equals to 2. Let's get. So the value of x equals to 2.